This screencast is about net ionic equations, and I'm going to show you this is one of those weird things that appears complicated in the beginning, but is actually very easy to understand. But what you do have to do is you have to be able to understand the regular equations that we've been working with fairly well, and then you can understand net ionic equations. It's just a small step further. So if you're not very good with chemical equations, this is going to be a little complicated. But if you're pretty good and you feel confident about balancing and knowing what the products are and understanding that there are some products that are solids, then this is going to be actually pretty easy for you. And I suspect, from what I can tell, that's going to be pretty easy for many of you. So let's take a look at this. I'm going to go talk just quickly through the steps, and then we'll do two problems. I want to make sure that you guys are okay with that. So complete and balance the equation if necessary. So step one is be good at chemical equations. Step two is everything that's aqueous. Now that means that if you have something in a chemical equation that has an AQ after it like that, that means it's aqueous. Okay, so what's going to happen is we're going to transform that into this. Okay, and actually, to be more specific, I'm going to transform something that looks like this into, and that would say aqueous also. Take a look what I do with the subscript. For the 2 here, that 2 there is there because of crisscross. Okay, the 4 isn't. That's part of the polyatomic ion. You guys know that already. But notice that when I break a compound down into its ions, that when I have a subscript that's there because of crisscross, then it becomes a coefficient. Okay, that's one of the changes that's going to, once you understand that, now you are understanding most of what net ionic equations, what trips students up. So let's take a look at 3. Look for the ions that end up on both sides of the equation. This is an easy part. They don't do anything. Those are spectator ions. That means if you see an ion on one side of the equation and you see it on the other side and it hasn't changed, then it's going to be a spectator ion and you can cross them off. So what you're left with after you cross off in step number 3 is you write everything down that you still have that you haven't crossed off, and that's your net ionic equation. Okay, so this is the net ionic equation, the parts that have not been crossed off. Let me show you an example and show you what's going on. So here's my equation up here. You can see up here that I have PbNO32. That's aqueous, so I'm going to break that up so it looks like this. It's going to be Pb with a +2 like that, plus, and then notice this 2 here is from crisscross, so it's 2NO3 with a -1, and then plus. Now this is also aqueous, and I have a 2 in front, so that doesn't change. I want to make sure I balance this whole equation. I can do that. If I take a quick look at this, I can see that the balanced equation has a 2 at the end here. Okay, so I have to make sure my equation is written correctly and balanced before we do the net ionic equation stuff. So there's 2 K's with a positive here, and there's also, if you see this 2 is also for the 2 Cl's with a negative. Okay, so then the other side here, notice that my PbCl2 is a solid. This does not change. So if I have a solid, a liquid, or a gas, I do not break it down into ions. I keep it the same. And then I have my plus, and then notice I put the 2 in front for the KNO3, which means I have 2 Ks and I have 2 NO3s, like that. Okay, now I'm going to use a different color, and we're going to take a look after I've written everything out, including moving the subscripts to coefficients like I did for, well, those were coefficients already, but some of them I moved from subscripts to the coefficients. So I'm going to go through here and I'm going to simply cross off everything that doesn't change from one side to the other. Notice that the NO3 here doesn't change from one side to the other. Notice that the K positive, the K plus, does not change from one side to the other. Okay? That leaves me with, as a net ionic equation, Pb with a +2 plus 2Cl minus And then on the other side, I have PbCl2 as a solid. And that's it. That's what you do for a net ionic equation. So we're crossing off, we're putting everything into ions, and then we simply cross off everything that shows up on both sides of the equation. So let me do one more example. One that has, you have to complete the problem. I'm not going to, you guys have done this stuff already. I'm going to go to one that looks like this. Let's try something like, ooh, this is a good one. How about beryllium iodide plus strontium sulfate? So for this, you're going to need your periodic table of ions. Okay, you'll probably need your equation test sheet to help you with this. And you should be good to go then. So I'm going to write out the stuff that says for the normal equation, which means I need to write this whole thing out here. Beryllium has a +2. My first step, we've been doing this for a while now, so this shouldn't be a shocker to you. Beryllium has a +2. I'm going to write out symbols and charges. Iodide is a -1. Strontium is a +2. Sulfate is SO4 with a -2. On the other side here, if you guys remember, this is a double displacement reaction because I have a compound plus a compound, which means on my other side I'm going to get A going with D and C going with B. So it's going to look like this. For my A is BE with a +2. My D is SO4 with a -2. That makes it nice and easy for crisscrossing. My C is SR with a +2, and my I is a -1. So when I crisscross these, I put a 2 down here and get rid of the charges. On this side here, I get rid of the +2 and -2, and then here's a +2 and a -1, which I crisscross like that. I check to see if I have everything balanced. It looks like it's all balanced. Now, here my first step is to look at the equation test sheet. On the back is where I have the solubility chart. If you look on the solubility chart, you will see this. It will say AQ for BeI2. It will say solid for SrSO4. You will see AQ for BeSO4 and AQ for SrI2. So that means for the complete ionic equation, I'm going to split everything up into ions, change the subscripts into coefficients for most of them. Notice that the SrSO4 stays the same because it's a solid and not aqueous. The rest of them on this side change though. There. Now all I do is take the ones, I cross off the ones that are the same on both sides, which means the BE goes away. The I minus goes away. And what I'm left with then looks like, let me scroll down a little bit. What I'm left with then is an equation that looks like this. And that's the answer. All right, guys, we're going to try and do some class time. If it's period 4 and you're a hybrid student, you'll get some class time and some chances to ask me questions. If it's period 5 and you're online, then please message me or ask for a Zoom and we'll go over more of this. Thanks for listening.